Good evening, sir, and good evening, everyone. Today we are going to study about the lichens and its importance. In the five kingdom classification of Whittaker, there is no mention of some acellular organisms like virus and viroids and lichens. A lichen is a long-living composite organism that arises from algae or cyanobacteria. They living among the filaments of a fungus in a mutually beneficial relationship. The algal component of a lichen is known as a pycobient, and the fungal component is called microbiont. The fungus benefits from the symbiotic relation because algae or cyanobacteria produce food by the photosynthesis, which is utilized by the fungus. The algae or cyanobacteria benefits by being protected from the environment by the filaments of the fungus, which absorbs moisture and nutrients from the environment and provide an anchor to it. Such relation in which both organisms are benefited from one another is called symbiosis. There are about 400 genera. Sir? There are about 400 genera and 15,000 species of lichens. They are found worldwide. They are usually grow on the barks of trees, dry logs of wood, and bare rocks. They are xerophytes in the nature and can withstand a long period of drought. Type of the lichens. On the basis of the fungal compounds, lichens can be divided into three types: ascolichens, basidiolichens, and deuterolichens. Ascolichens, the fungal partner belongs to Ascomycetes. Basidiolichens, the fungal partner belongs to Basidiomycetes. Deuterolichens, the fungal partner belongs to Deuteromycetes. On the basis of the thallus, the lichens can be divided into three types. First one is crustose lichens. In this case, the thallus forms crust-like structure. It closely adheres to the substrate. They are found on the bark or rock. The examples of the crustose lichens are graphene, lecanora, hematoma. Next one is foliose lichens. In this case, the thallus has leaf-like lobes. They are fixed from the substrate by airy rhizoid-like structure called rhizanes. They are attached only at the central points. Examples for these lichens: Parmelia and Colema peltigera. Fruticose lichens. Their thalli are cylindrical ribbon-like and branched. It is attached only at the base by the basal mucilaginous disc. They are commonly called as shrubby lichens. Examples for Cladonia, Usnea, Alectoria. Lichens we can use economically. The economic importance of lichens, they are used as a food. In Iceland, Sardinia, Satyria Icelandica is commonly known as Iceland moss. Is grounded up and mixed with the wet flour. A leathery lichen, Umbricularia, commonly known as root tripe, has been eaten by the travelers in Ice. Travelers in Arctic regions in danger of the starvation. Two species of Lecanora have been used as a food in the barren plains and mountains of Western Asia and Northern Africa. Certain classes of East Siberian inhabitants use lichens as a vegetable diet. In Tamil Nadu, the species of Parmela known as Telugu as Ratapu, a rock flower, has been used in curry preparation and is famous for its delicacy, and it's also used for the preparation of the chocolates and pastries. Lichens used in the industrial use. The lungwort lichen is used in tanning and in perfumery. The cell wall of the fungi certain lichens containing coloring matters. The species of Rosella and Lecanora yield a most important coloring matter known as archilla or cudbear. This is used in coloring woolen and silk fabrics. It also used for manufacturing litmus papers, which are used in the laboratories for the acid and base identification. It is obtained from the Rosella mountain. In Russia and Sweden, the lichens used for the production of alcohol. Some lichens are used to manufacture Avan samagri like dupa, agarbattis and other perfumes due to their pleasant smell. Some lichens are harmful to the industrial products because they cause considerable damage to glass surfaces and marble stones due to itching. Lichens needs a clean hair. Although they are tough and can survive in extreme climates, including extreme climate, heat, cold, and drought, they are sensitive to air pollution. Because they are so pollution sensitive, some scientists use them to assess the air pollution coming from the industrial plants and urban areas. They observe everything from the air, including carbon dioxide and heavy metals. Scientists can extract toxic compounds from the lichens and determine the level of the air pollution in a given area. The drying of lichens at a site is an early warning of the sign of the harmful pollution. Lichens contribute to soil formation. Lichens thrive in the undistributed sites where nothing else will grow. They grow on box, barren soils, and then bark of dead or live trees. They are not parasitic when they are grow on trees. They just use the tree bark as a home. They enrich the soil by trapping water, dust, and sleep. When lichens die, they contribute organic matter to the soil, improving the soil so that the other plants can grow there. They releases carbonic and oxalic acid, which leads to weathering of the rock and it leads to the formation of the soil. This process is called pedogenesis. Lichens used in the medicinal field. Histamic acid obtained from the Usnea and Cladonia species is used as an antibiotic against gram-positive bacteria. The Peltigera canina, the dog lichen, is used as a medicine for hydrophobia in ancient days. Loboria pulmonaria, the lungwort, are used for the disease of the lungs. Parvelia is useful against the epilepsy. Usnea species are good against the urinary diseases. Xanthoria species is used in jaundice. Some lichens possess anti-carcinogenic properties.